There's the dirty water after derusting the speaker basket, after rinsing it off and drying it real well. I'm going to give this thing a coat of polish and probably not even paint the frame itself. That will act as a rust inhibitor. That looks pretty good as is. After using a little Mother's mag and aluminum polish, again, that will act as a rust inhibitor as well. And you can see the speaker basket cleaned up really well. Not worthy of painting at this time, that's for sure. And a look at the center pole piece, derusted and polished up as well. As you can see, the center pole piece, roughly 1/2 inch, just like the other Philco. As you can see, I've got the audio output transformer here hooked up to my little Arduino tester that I built and shared some time back. Lets me measure the turns ratio. And you can see this particular transformer for the PT-26 should be around 25 on the secondary itself. If it was hooked up here, I just have 11 turns of wire around the core, and you can see that gives me a turns ratio of roughly 199 to 1. I can take that math with the 11 turns, the turns ratio that I just mentioned, 199 to 1. I want a transformer with a turns ratio of 25 to 1 for this particular output tube, assuming I'm using a 4-ohm loudspeaker to get close to 2500 for the load resistance. Anyway, if I divide that to 199 by 25 gives me 796. I can multiply that by 11, gives me 88 turns for the secondary. I can take the 88 times 25 and roughly 2200 turns on the transformer for the primary. Thought I'd share that. Hope you guys are having a wonderful day. There's the number on the output transformer, 557, looks like 56 or 58. And I cannot make out the other nomenclature on that side. This thing's been exposed to a lot of moisture, you can tell just by the amount of rust. Since I'm rebuilding the loudspeaker and this thing is mounted back to it, I'm going to go ahead and just break the laminations apart. I'm going to count the number of secondary turns. Hopefully they're on the outside. That's usually the case on these little small transformers. We'll see in just a bit. Let me get this thing apart and count the number of turns, and I'll bring you guys back and disclose that number for the secondary. Sometimes the top piece here can be stuck to the laminations. Just using the cold chisel there to break it loose, and the vise makes it simple and easy. And you can see the simple construction of this audio transformer. Try to get my hands out of the way, just the E's and I's and the I down here on this end piece. I'm going to take note of that core as well, just do the math on that. Again, the output tube itself is just north of a little over 1 watt of output, so just a small output transformer. See if I can measure this. So about 13 and roughly the same. So that is give us our 13 times 13 will give us our square millimeters. See if I can do this one-handed. Press down. All right, let me set the camera down, but you can see it separating. And a piece of tape I'm going to place on here just to keep all the laminations together. And there we have it. The E pieces and the I's. And just using a little alcohol to clean that off. 5575B is in Baker is the part number. All right, 21 turns down to the bottom. And we'll start unraveling back to the top now. And now 42 from here back to the, I'll call it the top. And another layer removed, 67 to this point. So around 92 turns for the secondary. Pretty close to our calculated number. All right, let's take a look at the primary winding. There's the solder location on this one. The common point of failure for those that have watched in the past. You can do many repairs this way. Be curious to see what wire gauge was used. Very fine wire, as you can see. Let me take my micrometer and see if I can measure this. Let me clean it up just a bit. Most likely a 36 to 38 AWG. 0.0065. Probably closer to a 35 or 36 AWG. I'll look at the B plus current requirements for the output tube and just try to size the wire accordingly. All these were stretched. That's why many of the output transformers back in the day opened up on the primary side. I think I can repurpose the bobbin. I'm going to go ahead and cut down to the cardboard and see. I also got down to a point where I can take off 10-20 feet of wire. I'll measure the DC resistance as well and see what closely matches this. Okay, 10 feet, 4.9 to 5 ohms. This is probably closer to a 36.5 AWG. Again, I'll just go back and reference the data or schematic for the B plus side feeding through the output transformer. I think it's somewhere around 38 to 41 milliamps of current. And the secondary side, so probably somewhere close to a 22 or 23. This may have been, again, one of those half gauge wires from back in the day. And there's the very simple cardboard bobbin that was created back in the day. I'm going to look at the core in millimeters. I think I said 13 to 14, just using my ruler. So a little over 13 this direction. And just under 13 millimeters in this direction. I'll flip this around, look at the other side as well. So just under 7 millimeters. So look at the window to work in. Looks like right at 7 millimeters. We'll just call it 7 even. to work with. That will be for the wire in addition to any tape that's placed in there. And the height of the bobbin right at 20 millimeters. So I mentioned using that same bobbin, and that's what I'm going to attempt to do. You can see I've built some collars to go on the end, real thin plastic. Rough the edges up, and I've got some epoxy on this one side. Then I'll reverse this in a couple hours and do the other side. Make sure I've got a good fit inside my window area. That will help me keep the 35 AWG, which will be my primary wire gauge, from coming off the ends as I wind this. Here's the humbucking coil and the fill coil just dressed back up where the leads were frayed, ready to be reinstalled into a usable receiver when that time comes. I took the tap and die set, and you can see I've tapped this center pole piece so I can fasten it back or pull it back toward the back plate and hold it securely in place now. Reinstalling the humbucking coil and the fill coil, and again the new lead wire dress. Let me see if I can get that center pole piece back in now. Okay, shims in place around that center pole piece. Let me see if I can drive that back in close to being flush, and then I'll take the tapped center pole piece and see if I can pull it back toward the back plate. Okay, there's the number 8 screw after doing the tap, and you can see I've got a flat washer. You can't see the locking washer, and then I have a number 8 finish washer on there as well to take up some of the space. And I think I've got the center pole piece centered best I could. Anyway, I'm going to try to reuse the existing OEM Spider, even though you can see the voice coil itself is only raised probably a 0.5 millimeter above the Spider. I've got the leads tied in for the voice coil. Just checked it. Ohms out around 3 to 3.1 ohms DCR. I'll put some epoxy on the leads back to the homemade cone, again assuming I'm able to use the Spider and the voice coil configuration. You can see the shims in place as well. I'll leave those. Just doing a dry fit of the surround that I cut, again out of a donor, and just doing some paper copies right now of some different cone heights, widths, etc., to make sure that I've got the best fit possible. Okay, I got the new paper cone glued back to the donor surround, and as you guys saw, I didn't have really much height on the existing voice coil, but I'm going to give this a try. I've got some epoxy applied around the cone at the voice coil, and I've just got just a little bit of weight pressing this down while the epoxy dries to see if that's going to work or not. Time will tell. And if that does work, I'll go back and put some adhesive down around the surround and reattach the existing gasket. So you can see the new cone I've sealed around the surround where it meets the homemade cone. Got the gasket in place and still got shims there around the center pole piece at the voice coil. Still need to put some epoxy on the voice coil leads on the back of the cone and seal the back of the cone as well where it meets the surround. I'll do this after that dries for a few hours. You can see the output transformer. I took the former or bobbin, put those end pieces on, let that dry overnight. I'll be winding a new output transformer soon, starting with the primary winding. Easy now.
As I went down in the river to pray, the shame's done all it's stealing, and you're desperate. Out in the cold.
Winding the primary of the transformer now. About 2,200 turns is what I'm shooting for. And roughly 88 for the secondary, giving me a turns ratio of around 25 to 1. You can see it's not going to take too long to wind this. RPM 190, 191. Again, I'm using 35 AWG magnet wire, and that should give me somewhere capacity wise around 44 milliamps of DC current. Still moving along, no issues so far. Coming up on 1,300 of our 2,200 turns. Well, you can see me coming up on 2,000 turns. Again, I don't have to have exactly 2,200. I'll just stop it here as close to 2,200 as possible, or maybe just a little over. We'll divide that number by 25 to get the turns ratio that we need. All right, we'll hold it right there. I'll check DC resistance in just a bit. Put a layer of transformer tape across the primary, then I'll probably just hand wind the 22 AWG, roughly 88 turns. And you can see roughly 166, 167 ohms DC resistance. And you can see just a little double coated 444 tape placed just a bit on here. So when I wind that first layer, hopefully I can keep it intact. Then I'll put another piece down for the next layer and continue that process until I get my 88 turns. My first test of the output transformer, after winding the secondary, I may throw another turn or two on there, but pretty close to my 25 to 1. But that's where we're at. Let me do the lead dress. Get this thing back installed on the speaker. And after doing the lead wire dress, see if I can squeeze this thing back into the laminations now. All right, there's the rewound transformer. Again, not a high quality transformer, probably handles about 2 watts. Let me get the little Arduino turns meter over here and let's see what we have. Okay, that's pretty close to my design, shooting for 25 to 1, and let's see if you guys can see that, about 24.83 to 1, so close enough. And you can see how I have the program written. If there's a 4 ohm impedance loudspeaker attached to the secondary, the impedance should be just under 2,500 ohms, which would be a good match for this receiver. And you can see I've got it tied into the little 4-inch loudspeaker that I rebuilt. Again, I don't have the humbucking coil hooked up yet. That will change this reading, but you can see the reflected impedance again right at 2,500 ohms back to the primary side. And here's a look at the impedance sweep of the loudspeaker itself through the humbucking coil in series. And you can see at 1 kilohertz, we're right at 4 ohms. And again, that's what the speaker was designed for. And there's a look at the completed loudspeaker back together with a rewound output transformer, humbucking coil attached as well. So you can see the parts scattered back here on the back side. I'll get those cleaned up and do some testing on the ones that need to be tested. The old chassis, just giving it a wipe down. And underneath the chassis now, still some cleanup to be done here as well. Should make for a fun project as time permits. Thanks for watching.